Hey guys, welcome back to my channel. Today we are going to talk about operating systems. This is a new series. In short, it is called as an OS. In this video, I'm going to be covering the definition of OS and the different components of the OS that we will learn in this series. It will eventually help us understand how to design a very efficient OS. So what is an OS? It is a computer program that gets loaded into the memory by BIOS, which is basic input output system. It is a program that a computer's microprocessor uses to start the computer system after it is powered on. Okay, so whenever the system is booted up, it's a pre-loaded program by the vendor who's selling any computer system. Like Microsoft sells you a laptop, they will load the Windows OS into the into the memory, and the BIOS will start it. It will run that particular OS program. So any device that has hardware which involves memory, CPU, disk space, and it helps in running software applications on top of it, okay, will have a dedicated OS. It could be your phones, laptops, tablets, it could be your infotainment systems in the car, it could be smart home devices, AirPods, the AR, VR glasses which are coming out these days. So all of these require its own dedicated operating system to manage the hardware and the software. So it's the operating system is like an interface between the hardware and the software. Okay, it helps in running multiple applications while using the hardware and software resources appropriately based on their needs. It makes sure that it's fair and efficient and also easy to use. Now, these applications, right? So if you open a Windows Task Manager, you can see what are the applications running, and each application has a process associated to it. Okay, so you can see that in your task manager. You can see the number of processes. Each application has a number of threads. Each process has all of that. And what are these applications? These applications are nothing but a software program. So what happens when we run this software program? It does one very simple thing. It executes instructions. These days we have billions of lines of code for a particular application, and the processor in the computer fetches one instruction from the memory, decodes it, figures out what the instruction is, and executes it. It could be like adding two numbers together, accessing a memory, checking a particular condition, jumping to a function, and so forth. After it's done with this instruction, the processor moves on to the next instruction, and so on until the program finally completes. Since we have multiple applications which can run on a computer, and we probably have limited number of processors to manage these applications, there has to be a scheduling mechanism. There has to be a resource manager, okay, who will manage all these efficiently, fairly, and reliably. So it makes sure that each application gets the processor, and it does not, no application should hog the processor for a very long amount of time. Okay, otherwise then it does not become fair. Then one application is hogging all the processor, and then the other one is left behind, so it's gonna make it very inefficient. So that's where the operating system plays a role in managing all of this. Sometimes it's also referred to as a resource manager. So we're gonna learn in detail about the process management, what are the different kind of algorithms that can be used to schedule these processes. Okay, we're going to talk about multi-threading. We're going to talk about concurrency, because whenever multi-threading is involved, it is basically accessing one block of memory and the chances of deadlocks. So we're going to talk about locking, we're going to talk about semaphores. Okay, then we're going to talk about memory management. Each application requires its own memory. We do not want one application to write or edit the memory of another application, right? So there is memory management, there is paging. In that, we're going to learn about paging. Okay, then there is also the disk space which comes in the computer. Okay, the operating system that usually manages the disk is called the file system. We're going to study about that. We're going to talk about virtualization, how the CPU is virtualized, how the memory is virtualized for different applications. Okay, sometimes nowadays we have, the containers and VMs, virtual machines, which are running on computer systems, right? So each VM will have its own set of CPUs. It will have its own set of memory. It will have its own set of disk space. So all of this has to be, accommodated by the operating system. So we're gonna see about that. We're gonna talk about the security aspect of the operating system, how the kernel needs to manage its resources securely and reliably. We are going to talk about the distributed systems. So these are the topics that I'm covering in this course, in this series. Okay. So once we have the knowledge of all these components, right, we will understand how to provide a high performance operating system. At the same time, it should be fair. It should not add a lot of overhead, that is extra time and extra space. It also should be secure and reliable. Okay, so once we complete this course, we should have an idea. We should have, and we will understand, how operating systems are designed. It will also give you an insight on how to write good code. Okay, so please do let me know in the comment section if there are any other topics on operating systems that you want me to cover which I might have missed. So I'm gonna be starting with the memory management first. My next few videos are gonna be on that. Please do like, share, and subscribe. Thank you.